In this video, we are going to look at finding the factors of a number, knowing what a prime number is in order to find the prime factors of a number, and in finding the prime factors of a number, understanding what is meant by the fundamental theorem of arithmetic. The factors of a number are all the numbers that divide exactly into that number. So, for example, the factors of 6 are 1, 2, 3, and 6. And this is because 1 multiplied by 6 is equal to 6, and 2 multiplied by 3 is equal to 6. The factors of 15 are 1, 3, 5, and 15. And this is because 1 multiplied by 15 is equal to 15, and 3 multiplied by 5 is equal to 15. The key to finding the factors of a number is knowing the multiplication tables. I am going to use a specific approach to finding the factors of a number. We need to find the factors of 24. Well, a good starting point is to start with the factor 1. 1 multiplied by 24 is equal to 24. So 1 and 24 are factors of 24. Well, let's look at the number 2. 2 must be a factor of 24 because 24 is an even number. Well, 2 goes into 24 12 times. 2 multiplied by 12 is equal to 24. Therefore, 2 and 12 are factors of 24. Moving on to the number 3. Well, I happen to know that 3 multiplied by 8 is equal to 24. So 3 and 8 are also factors. Moving on to 4. Well, 4 multiplied by 6 is equal to 24. So 4 and 6 are factors. Moving on to 5, well, 5 actually doesn't go into 24 exactly. So 5 isn't a factor. And if we move on to the next number 6, well, we've already done 6 and 4, which is equal to 24. We don't need to go any further. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. If I wanted to find the factors of 18, again let's start with 1. For 1 multiplied by 18 is equal to 18. So 1 and 18 are factors. 2 must also be a factor of 18 because 18 is an even number. Well, 2 multiplied by 9 is equal to 18. So 2 and 9 are factors. Moving on to 3. Well, I know that 3 goes into 18 6 times. So 3, because 3 multiplied by 6 is equal to 18. Notice this is just knowing the multiplication tables. I happen to know that 4 is not a factor because 4 doesn't go exactly into 18. And also 5 doesn't go exactly into 18. So 4 and 5 are not factors. If we then move on to 6, well, we know that 6 multiplied by 3 is equal to 18. We've already done 3 and 6. So the factors of 18 are 1, 2, 3, 6, 9, and 18. So that's how we can find the factors of a number. Now let's look at trying to find the prime factors of a number. All numbers can be written as a multiplication of prime numbers. Now, a prime number only has two factors, one in itself. Here are the first 10 prime numbers. These numbers only have 2 factors. So 2 only has the factors 1 and 2, 3 only has the factors 1 and 3, 5 only has the factors 1 and 5, and so on. Notice that the smallest prime number is 2. It also happens to be the only even prime number. Notice that 1 is not a prime number. 1 only has one factor, and we're going to be coming back to 1 later on. So, what are we talking about when we're talking about prime factors? Well, for example, if we look at the number 6, 6 can be written as 2 multiplied by 3. 2 multiplied by 3 is 6. 2 and 3 are both prime numbers, so those are the prime factors of 6. 15 can be written as 3 multiplied by 5. 3 multiplied by 5 is 15. Both 3 and 5 are prime numbers. If we had, for example, 12, well, 12 can be written as 2 multiplied by 2 multiplied by 3. Remember, 2 multiplied by 2 is equal to 4, then 4 multiplied by 3 is equal to 12. And how we would write that is like this: 2 squared multiplied by 3. Again, in order to find prime factors of a number, you need to know the multiplication tables. I'm going to have a look at an approach to finding the prime factors of a number. I'm going to look at the number 30, but I'm going to use the method in 3 different ways. So starting with 30. So I'm thinking, right, 30 is equal to 3 multiplied by 10. Notice how I'm writing it down. 3 and 10 are both factors of 30. 3 is a prime factor, because 3 is a prime number. 10, however, isn't a prime number. So we now need to break 10 down into its prime factors. Well, I know that 10 is equal to 2 multiplied by 5. Well, 2 and 5 are both prime numbers. I have now broken 30 down into its prime factors. 30 is equal to 2 multiplied by 3 multiplied by 5. And that makes sense, doesn't it? 2 multiplied by 3 is equal to 6. 6 multiplied by 5 is equal to 30. I could have done it slightly differently, starting with 30. Well, I happen to know, because 30 is an even number, I know that 2 must go into 30. Well, 2 goes into 30 15 times. 2 and 15 are factors of 30. 2, however, also happens to be a prime factor, because we know that 2 is a prime number. But 15 isn't a prime factor. We can actually break 15 down into 3 multiplied by 5. 3 times 5 is 15. And that's it. We now have our 3 prime factors: 2, 3, and 5. Notice that despite breaking 30 up or doing this differently, still has produced the same answer. Let's do this one more time. 30. Well, I know my multiplication tables. I know that 30 is equal to 5 multiplied by 6. 5 and 6 are both factors of 30. 5 is also a prime factor of 30, because 5 is a prime number. 6, however, is not a prime number. However, this can be broken down into the factors 2 and 3. 2 multiplied by 3 is equal to 6. 2 and 3 also happen to be prime numbers. So, 30 is equal to 2 multiplied by 3 multiplied by 5. I've used the same approach 3 different ways. However, when I get down to the prime factors, I still end up with the same result. 30 is made up of the prime factors 2, 3, and 5, because 2 times 3 times 5 is equal to 30. So you may be required to find the prime factors of a given number. Here are 3 numbers for you to try: 140, 88, and 300. I'm going to find the prime factors for these numbers, but you might want to pause the video just to have a go yourself. Now, the key thing here is that you should have the same answer, even if you didn't break the numbers down in the same way that I did. Let's have a go. 140. I happen to know that 140, I can break this down into 14 and 10. Because it ends in a 0, I know the number is divisible by 10, so let's just make it easy. I've got 14 and 10. You could have divided it by 2 and ended up with 2 and 70, but that's how I've done it. Well, 14 and 10 are both factors of 140, but neither of these numbers are prime factors. So I need to break these numbers down further. I know from my multiplication tables that 14 is 2 and 7. Similarly, with 10, I know that 10 can be broken down as 2 and 5. What we have here are the prime factors. 2, 7, and 5 are all prime numbers. So these are the prime factors of 140. I need to write it like this. I've got 140 is equal to 2 multiplied by 7 multiplied by 2 multiplied by 5. That's what I found out. But let's tidy this up. I have 2 here multiplied by 2 here. I can write that as 2 squared. I then write down the 5 and then the 7. So notice I've started with the smaller of the prime factors, make my way up to the largest of the prime factors. Let's do the number 88. 88, I know, is 8 multiplied by 11. 8 and 11 are factors of 88. I also happen to know that 11 is a prime factor, because 11 is a prime number. So I now need to focus on 8. Well, 8 is 2 multiplied by 4. 2 is a prime number, but 4 isn't. Well, let's break the 4 down into 2 multiplied by 2. I can't go any further with this. I have now found all the prime factors of 88. So the prime factors of 88 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 11. And I can write this 2 times 2 times 2, I can write as 2 cubed multiplied by 11. Finally, let's look at 300. Again, there are different ways you could do this. 300 is obviously divisible by 100. The factors of 300, so if 3 is a factor, 100 must be a factor. 3 also happens to be a prime factor because 3 is a prime number. 100, well 100, I'm going to say is 10 multiplied by 10. Now 10 is not a prime number. I can actually break 10 down into 2 and 5 and 2 and 5 because 2 multiplied by 5 is equal to 10. 2 and 5 are prime numbers. I can't go any further. So I can write 300 as 3 multiplied by 2 multiplied by 5 multiplied by 2 multiplied by 5. And let's just tidy that up. I have 2 squared, because I've got 2 times 2, multiplied by 3, and I've got a 5 times 5, so that's going to be 5 squared. So those are the prime factors of 300, and you should have got the same answers, even if you'd done it slightly differently. It's important to note, as we've seen with these examples, there is a unique way in which any number can be written in terms of its prime factors. This is called the fundamental theorem of arithmetic, and this leads us back to the number 1 and why 1 isn't a prime number. 1 has a special property, and that is that any number multiplied by 1 produces that number. I'll show you what I mean. We know that the prime factors of 30 are 2, 3 and 5. But what if 1 was a prime number? Look what happens now when we find the prime factors of 30. Well, in terms of its prime factors, 30 could be written as 1 multiplied by 2 multiplied by 3 multiplied by 5. But also, 30 could be written as 1 multiplied by 1 multiplied by 2 multiplied by 3 multiplied by 5, which we would write like this: 1 squared multiplied by 2 multiplied by 3 multiplied by 5. We could also write 30 as 1 cubed multiplied by 2 multiplied by 3 multiplied by 5, and so on. If we count 1 as a prime number, suddenly we could have an infinite number of ways of writing a number in terms of its prime factors. So this is one of the key reasons why 1 is not a prime number. Anyway, that's all I'm going to be doing on factors and prime factors. I hope you found it helpful, and thank you for watching.